Good morning, students. Let us do problems on Newton-Raphson method. The first problem is apply Newton-Raphson method. Apply Newton-Raphson method to determine the root of cosine x minus x into e power x equal to 0 such that modulus of f of x star is less than 10 power minus 8, where x star denotes the approximation root. X star is the approximation root. Take the initial approximation as x not equal to 1. Here in the problem, initial approximation is given. Take the initial approximation as x not equal to 1. Solution. The initial approximation is first the initial approximate root. The initial approximate root is x not equal to 1. Okay. The NRM iterative formula is what is the formula? Xn plus 1 is equal to xn minus f of xn by f dash xn. This is NRM formula. Take this as equation 1. Already initial approximation x naught is given. So when n equal to 0, at n equals to 0, what is x1 equal to? X naught minus f of x naught by f dash x naught, right? So I have to calculate what? F of x naught and f dash x naught. Here, what is f of x? The function is given as cosine x minus x into e power x. And what is f dash x then? Minus sine x. And this is UV method, x derivative 1, then e power x as it is, next this one. This is f dash x, right? So what is this case? X naught value is what? 1 minus f of x naught, f of 1 by f dash 1. Substitute all these values. This is 1 minus f of 1 means what? Cos 1 minus e to the power of 1 by f dash 1 minus sine 1 e minus e. Okay. So after calculating all these values, we are getting 1 minus 0.34692060. So that gives 0.65307940. This is the first approximate root x1. Coming to x2. Now what is x2 is, again from equation 1, if I put n equal to 1, x2 is x1 minus f of x1 by f dash x1. This is what is x1 now. X1 value is 0.65307940 minus f of the same thing 0.65307940 by f dash of 0.65307940. So after substituting in this function f of x and f dash x, in place of x substitute this value, complete 0.65307940. So the value of x2 is 0.53134337. x3 is, what is x3? x2 minus f of x2 by f dash x2. Now you know what is x2, just I'm giving direct value. X3 value is x1, x2, x3 value is 0.51790,991, and x4 value, x3 minus f of x3 by, you have to do this on your class notes, okay, the substitutions and evaluations. X4 value is 0.51775738, and x5 value is, and one more point here, After calculating this, you calculate f of x3 value. What is f of x3 value? F of x3 value is minus 0.4641 into 10 power minus 3. And here f of x4 value, in the function substitute x4. Function is what? Cos x minus. So for your clarification, for one term I will write x4 into e to the power of x power 4. Substitute x4 value, f of x4 is minus 0.5926 into 10 power minus 7. Okay, and x5 value is x4 minus f of x4 by f dash x4. F dash x4. So this value is 0.51775736, and f of x5, if I calculate, this value is minus 2910 into 10 power minus 10. What is the question? What is the given? What is the given condition? Given modulus of f of x star is what? Less than 10 power minus 8. Here what I am getting, modulus of x4 is less than 10 power minus 7. Okay, approximately one can say this is, what is this, minus 0.5926 into 10 power minus 7. But what is modulus of f of x5? It is less than minus 2.2910 into 10 power minus 10. So this value is less than, it is less than 10 power, this is less than 10 power minus 8. Therefore the approximate root is x star is nothing but x5, that is 0.51775736. It's a problem in Newton-Raphson method. Let us consider another problem. Find the smallest positive root. Find the smallest positive root of the equation x cube minus 5x plus 1 equals to 0 by performing 4 iterations. Here the number of iterations are given. Okay, solution. How to calculate this? First, what is f of x? X cube minus 5x plus 1. Now here the initial approximate root x0 is not given. To apply a Newton-Raphson method, what we have to consider? Take initial approximation root x0, then what is exact root x0 plus h, like that. The procedure is given. So to select initial approximate root x0, first locate the interval. Locate the interval using which theorem? Intermediate value theorem. Intermediate value theorem. Using intermediate value theorem. Therefore choice is ours. I am taking arbitrary values for x. When x equal to 0, this is 1 greater than 0. When x equal to 1, 1 minus 5 plus 1, this is minus 3 negative 0. Since f of 0 into f of 1 both are having opposite signs, therefore product is negative. The root xi, exact root, belongs to what interval? Open 0 comma 1. Open 0 comma 1. Okay, isn't it right? Now let us choose, choice is yours. Let us choose the initial approximate root. X0 from this interval. Choice is yours, your choice. I am taking x0 equal to 0.5 belongs to open 0 comma 1. 0.5 belongs to open 0 comma 1. Then NRM iterative formula is, what is that formula? Xn plus 1 equal to xn minus f of xn by f dash xn. And what is f dash? Here what is f of x? F of x is x cube minus 5x plus 1. So its derivative is 3x square minus 5. Isn't it right? Therefore What is x1 root? First approximate root, x naught minus f of x naught by f dash x naught. So what is this? X naught value 0.5 minus f of 0.5 by f dash 0.5. You know the functions f of x and f dash x. Substitute those values, you will get 0.176471. This is the first approximate value. And coming to second root, x2 equal to x1 minus f of x1 by f dash x1, that is equal to x1 value 0.176471 minus f of 0.176471 by f dash of 0.176471. This value gives, after substituting in the functions and simplifying, you will get 0.201568. And next, x3 value, this is x2 minus f of x2 by f dash x2. Substitute this x2 value here, and what is x3 becomes 0.201640. Similarly, last iteration, perform 4 iterations. So fourth root is x3 minus f of x3 by f dash x3. This root is 0.201640. Therefore, after 4 iterations, the approximate root is 0.201640. Equation 1 gives xn plus 1 is equals to xn 2xn minus nxn square represents the intersection of the two curves y equal to x, left side y equal to x, and y equal to 2x minus nx square, this right side. Okay, if I draw these two curves, this y equal to x is a straight line, and this one is parabola. Now let me draw the graph. This is x-axis and this is y-axis, and this is origin 0, 0. Okay, and y equal to x is a straight line passing through origin. This is y equal to x line. And coming to draw the parabola, let me consider a table, just a rough table, n minus x square. When x equal to 0, y equal to 0, means again this point. When x equal to 1, this is 2 minus x square, 2 minus n, and so on. When y will be 0, again this y will be 0 when x equal to 2 by n. Okay, you consider so many points here, where if I consider 2 by n here, 2 by n comma 0, this point, at x equal to 0, 0, and at x equal to 2 by n, y value 0. So by joining these 2 points, I will get the parabola. This is the parabola. What is this? Y equal to 2x minus nx square, and in the one intersecting point is 0, 0, another intersecting point is this. To get that point, solve these two. Solving to get intersecting point, solving y equal to x and y equal to 2x minus nx square. What I am getting? X equal to 2x minus nx square. Put y equal to x here. So x equal to nx square. So x equal to 1 by n. So y also 1 by n. So what is the point here? 1 by n comma 1 by n. This is the point. Now if I choose, if x naught is beyond 2 by n, after 2 by n, that means this side, then the root diverge. Means not tending to exact root xi. Okay, if I choose here, if x naught is 0, if x naught is 0, then all the next roots, all the next roots will be 0, all the next roots will be 0. You can try this. Put x naught equal 0, get x1, x2, x3 and so on, all will be 0. See here, x naught 0, 0 means x1 0, similarly x1 0 means x2 0, like that you will get all these roots are 0. Therefore the initial root, the initial root x naught must lies between 0 and 2 by n. That implies 0 less than x less than x naught less than 2 by n. That means between this range. Okay, intersection of these two only the initial root must lies. Okay, next problem is find the iterative methods based on Newton-Raphson method for finding square root of n, inverse of n, 1 by n, cube root of n power 1 by 3, where n is a positive real number. Apply methods to n equal to 18 to obtain result corrected to two decimal places. Okay, let me take the first this one, x equal to root n. Let x equal to root n. When I choose f of x equal to directly from this x minus root n, then what is f dash x? 1. Then NRM formula becomes what? Xn plus 1 equal to xn minus f of xn, this one f of xn by f dash x. Then I will get root n. That means from this, what is x1 root n, what is x2 root n, x3 root n. So it always gives root n only, no recursive formula or iterative formula. So choosing the function f of x equal to x minus root n is wrong. So how to choose f of x? If I find the derivative of f of x, it should not be constant. Okay, for that I am squaring on both sides, x square equal to n. Now choose f of x as x square minus n. Then f dash x equal to 2x. Then NRM iterative formula, this is NRM iterative formula, and substitute f of xn and f dash xn here. After simplifying, I am getting xn plus 1 equal to xn square plus n by 2xn. This is NRM iterative formula. Okay, for what? Square root of n. Now what is n is given as 18. Let us take n equal to 18. Now NRM's iterative formula is this one for square root of 18. And square root of 18 means what? 4 point something, I think, right? So I am taking x naught equal to 4, nearer to the exact root, 4 point something, x naught equal to 4 by the initial approximate root. Then put n equal to 0 here, then I will get x1 equal to x naught square plus 18 by 2x naught. Substitute x naught value 4 here and I am getting 4.25. Similarly, put n equal to 1 in this iterative formula, x2 value is given, x2 equal to x1 square plus 18 by 2x1, that is 4 point this, and x3 equal to x2 square plus 18 by 2x2, substitute x2 value this. So correct to two decimal places, the square root of 18 is 4.2426. This is the square root of 18 value. Inverse of 1 by n, inverse of n, that is 1 by n. Let x equal to 1 by n. Then what is f dash x? This is only 1. So choosing f of x as x minus 1 by n is wrong choice. So let us reverse this. 1 by x equal to n. Now what is f dash x? Minus 1 by x square. Therefore choose the function f of x as 1 by x minus n. So f dash x is this. Now substitute in the NRM iterative formula. In this formula substitute f of x and f dash xn and simplify this. This is xn plus 1 equal to 2xn minus nx square is the NRM iterative formula for 1 by n. And what is n is given as 18. So 1 by 18 means what? 0.0 something. So I am taking initial approximation root as 0.1. Now in this one put n equal 0, get x1, that is 0.02. Put n equal to 1 here, get x2, then 0.03, x3, x4, x5, x6, and correct it to two decimal places. The root is 0.0556. Next, third case is cube root of n power 1 by 3, n power 1 by 3. Here let x equal to n power 1 by 3, that implies x cube equal to n. Therefore let f of x equal to x cube minus n, that implies what is f dash x? 3x square. Now NRM iterative formula is is xn plus 1 equal to xn minus f of xn by f dash xn. If I substitute in this formula, I will get xn. What is f of xn? Xn cube minus n divided by 3xn square. If I take LCM, 3xn cube minus xn cube plus n whole by 3xn square. Therefore, xn plus 1 equal to 2xn cube minus plus n by 3xn square is the NRM iterative formula. NRM iterative formula to find the value of n power 1 by 3. Okay, now what is n is taken as 18? N is taken as 18. Therefore, what is x1 formula? X1 is nothing but 2x0 cube plus 18 by 3x0 square. Okay, here let initial approximate root x0, initial approximate root x0, approximate root x0. The choice how to select the initial approximate. 18 means what is cube root of 18? It is all more than 2. So let me take 2, x0 equal to 2. So for this, if I substitute this 2 cube plus 18 by 3 2 square, okay, totally it is 2.8333. And next x2 equal to 2x1 cube. Now we got x1 value, substitute that x1 value here, 3x1 square. So this value is 2.6363. Similarly, x3 value is 2x2 square plus 18 by 3x2 square. This is cube. This is equal to x3 value is 2.6208 and x4 value is this is, if I write the formula, 2x3 cube plus 18 by 3x3 square. This value is 2.6207. Therefore, the approximate root correct to 2 decimal places is approximate root equal to 2.6207. 2.62 here, 2.62 here, correct to 2 decimal places, 2.6207. Now assignment problems based on assignment problems. Find the approximate root of the equations. First one, x power 4 minus x minus 10 equal to 0. Second one, x e to the power of minus x equal to 0. Okay. Third one, x cube minus 5x plus 1 equals to 0. And the fourth one, cos x minus x into e power x equal to 0. Using first one, bisection method. Second one, secant method. Third one, regular falsy method. And the fourth one, Newton-Raphson method. Okay, and one more problem. Fifth one, perform 4 iterations. Four iterations of the Newton-Raphson method to obtain the approximate value of 17 whole power 1 by 3. starting 17 whole power 1 by 3 starting with the initial approximation x not equal to 2, x not equal to 2. Okay, these are the problems, assignment problems, and you know how to solve this. Hint is, for this problem I'm giving hint is, let x equal to 17 power 1 by 3, that implies x cube equal to 17, therefore let f of x equal to x cube minus 17, f dash x equal to 3x square, and you know the procedure, how to find the root by using Newton-Raphson method,